How familiar are you with black holes? Ever wondered about the consequences of falling into one? Imagine this scenario. You are on a space exploration mission searching for a new habitable planet and unexpectedly encounter a black hole. Curiosity gets the better of you, and you decide to investigate. Let's explore the potential outcome of plunging into a black hole. Although termed as a black hole, this celestial entity isn't a void of darkness. According to Einstein's theory of relativity, black holes originate from the remnants of massive stars. When these stars exhaust their nuclear fuel, they collapse, leaving behind a condensed core. If this core's mass surpasses 3 times that of the Sun, gravitational forces dominate, leading to the formation of a black hole. Although the term might suggest otherwise, a black hole represents an immense concentration of matter compacted within an incredibly small area. Consider the Sun, with a gravitational pull 28 times more powerful than that of Earth. If you were to step onto the Sun's surface, you'd find yourself 28 times heavier than you are on Earth. Now, picture compressing 4 suns into a space merely 15 miles, 24 kilometers, in diameter, a distance you could traverse in just half an hour. What kind of gravitational forces would you encounter in such a place? A black hole's gravity is incredibly intense, to the extent that even light cannot escape its grasp. This phenomenon explains why observing a black hole directly is impossible. However, the detection of a black hole becomes feasible through the recognition of the gamma-ray bursts it emits. These bursts, famously associated with the findings of Stephen Hawking, now carry his name. Notably, Hawking himself postulated that black holes might serve as gateways to alternate universes. If one were to plunge into a black hole, could they potentially enter a different dimension? Each black hole features an event horizon, a boundary beyond which the gravitational pull becomes so overwhelming that escape becomes impossible. Outside this point, one would witness stars contorted into a perfect circle surrounding a void of darkness. The journey into a black hole would initially involve an accelerating movement, driven by the force of gravity. Unfortunately, this acceleration, a consequence of the extraordinarily potent gravitational field, brings the first piece of disheartening news for any intrepid space voyager. In the event of a feet-first descent, your legs would experience a more intense gravitational pull compared to your head. The fate of any entity approaching a black hole is one of extreme deformation. Referred to as stellar, the most typical black holes can extend up to 9 miles, 15 kilometers, in diameter and weigh as much as 20 suns. Should you find yourself drawn toward such a stellar black hole, you would be wholly torn asunder long before reaching the critical point of the event horizon. Therefore, opting for a supermassive black hole is crucial. These immense entities can be 1,000,000 times more massive than our Sun. Should you approach such a black hole, your body would remain intact while crossing the event horizon, experiencing nearly equal gravitational forces on both your feet and head. If you're curious about their location, you won't have to venture too far to find one. Indeed, our very own Milky Way galaxy houses one such supermassive black hole. Fortunately, it resides at a staggering distance of 165 quadrillion miles, or 265 quadrillion km, away from us, posing no threat to engulf the Sun or any of the planets. However, hold off on packing your bags just yet. Crossing the event horizon merely marks the initial stage. At the heart of the black hole lies a gravitational singularity, a point where density reaches infinity, presenting an entirely new set of challenges. Within the black hole, you would inevitably be compressed towards its center, merging with the singularity. Regrettably, you wouldn't be able to relay your experience to anyone. Yet, an external observer positioned beyond the event horizon would perceive an entirely distinct spectacle. As you descended into the black hole, they would witness your motion decelerating, your luminosity diminishing, and your color shifting towards the red end of the spectrum. Ultimately, you would effectively become motionless, forever halted right before crossing the event horizon. This phenomenon arises from the peculiar interchange of roles between space and time within a black hole. At the event horizon, time ceases to progress, while space continues its forward movement. Regrettably, just as you cannot reverse time, you wouldn't be able to pivot and flee the clutches of the black hole. Even as the black hole eventually dissipates, releasing all the particles it had previously consumed, including the remnants of your body, distinguishing whether those particles were once a part of you would prove futile. Nevertheless, Stephen Hawking devised a theory to circumvent this dilemma, positing that information concerning your physical being wouldn't be irretrievably lost. He proposed the existence of alternate universes characterized by distinct histories, thereby introducing a possible resolution to the enigma. Consequently, within one reality, you would have descended into the black hole, while in another, no black hole would have existed. From an external vantage point, confirming the presence of a black hole before actually entering it remains an impossibility. However, should you venture past the event horizon and encounter the black hole, it would signify a permanent and irreversible farewell. In such an alternate reality where the black hole did not exist, you would continue to exist, albeit in a separate universe, forever cut off from ours. Would you dare to entertain the prospect of such an exploration? Are you intrigued by the mysteries of black holes and the vast expanse of the universe? Prepare yourself for the forthcoming hypothetical journey that awaits you.